Hi, I'm Michael Moore. I'm from group number 2, and we're here to solve a very important issue. What is that issue? The drinking water problem. And our solution is solar stills.
We're going to start by talking about the problem. The stated problem is that there is a lack of clean, potable drinking water in many rural areas. Specifically, this affects the majority of people in underdeveloped regions. Some examples of underdeveloped regions include Africa, India, and Bangladesh.
So there are various problems related to water, scarcity of water and lack of clean drinking water. Some of them include dehydration and waterborne diseases. It's a known fact that 1 out of 5 children under the age of 5 die due to water-related issue. To tackle these problems and to solve these problems in rural areas, we have come up with a solution, the solar still. And this design will be explained by my colleague in a later slide.
One of the requirements for our solution is that it needs to provide clean drinking water, approximately 5 liters per person per day. And this water must also be usable for basic household activities such as cooking, drinking obviously, and sometimes even showering. And the water must be provided in adequate quantities because it is being used in large rural areas where there are lots of people.
One of the constraints for our solution is that it must be usable on days where it is not sunny or it is raining, for example. In order to account for this, we have included in our design a solar cell which will be charged up on the sunny days, and then this will be used to power up the heating mechanism which will work the solar still on such days. Another constraint we had to deal with was cost. Since we are installing these solar stills in rural and less developed areas, the cost must be less. Additionally, this also means that our design must be very simple in its maintenance because it is going to be used by less or not very well educated people who are not technically savvy.
The proposed solution of our team involves the basic principle of evaporation. The sun's solar energy evaporates the water by heating it up. This water vapor is then rising up and starts condensing on the glass surface. The water vapor is in its purest form, leaving behind all sorts of impurities. Thus, this water is then collected at another end, and that can be clear drinking water.
It works like an upside-down coffee maker. During the day, the heat of the sun rises up the steam pressure into the black boiler. The steam is forced through the expansion nozzle, thus condensation against the lid.
The social impact of the project is great because we're targeting the lowest strata of the society, which is often ignored and is worst affected when it comes to the problems of drinking potable water. When it comes to economic considerations, we have to keep 2 points in mind. The first is the initial cost of the project, and the second is the maintenance cost related to it. The way we worked on our project, and has already been explained by one of my team members, the initial cost is pretty low and the cost of maintenance is pretty low.
In conclusion, that was our group discussing the solution. Hope you liked the video.